Hi guys, this what you see is a 1.5 HP 4000 RPM permanent magnet DC motor. It is very heavy with this flywheel. So guys, today in this video I'm going to test its regenerative braking. This is a 180 volts 1500 watts DC motor speed controller, low high. Let's connect it to this motor. Everything is well connected. All I have to do is turn on the switch. Now guys, here as you can see I have stripped the wires a little on both red and black. So I'm going to connect the load terminals and the multimeter terminals to this wire, so that when I disconnect it from this motor controller, I don't have to connect the appliance after disconnection, because it is going to be very dangerous. Now guys, to make sure that the meter has been electrically connected properly here and there to this motor, let's turn it on, pointing it towards 20 volts DC mode, and I'm going to run this inertia disc to see if this display indicates some voltage. You see, voltage is being displayed. So yeah, it's electrically connected. Now guys, let's connect it to the converter and turn the setup on. So guys, as you can see that it has been connected. All I have to do is switch it on and then remove the wires of this motor from the converter, and then see how much voltage is being displayed on the multimeter screen, and that voltage will be the braking generation. Okay, first pointing it towards 1000 volts. Okay, go. 76 volts, increasing the voltage. 100 volts more. 130 volts, high speed, a little more. As you can see that it is flashing 180 volts almost. Now let's disconnect the terminals from the converter and see how the voltage falls. The disc, inertia disc, has been charged completely. You can see the disc has been charged, wires have been disconnected, and the voltage is slowly and slowly decreasing to zero. But it is still charged. Very dangerous. Still running. Now let's force stop the disc. And zero. Now guys, here I have not connected the black wire to this blue wire of this 100 watts incandescent bulb that we use in our houses. So anyways, let's charge this inertia disc of this motor. Okay, turning it on now. Let's increase the speed a little bit. At present I'm working with this setup at 50% power mode. Now let's disconnect the wires and touch this blue wire of this bulb, left out wire, to the black, and let's hope that this bulb glows. Okay. Wire disconnected. You see the bulb is glowing 100 watts. Slowly the illuminance is decreasing, of course. Let's brake stop it. Stop. Now guys, let's try this 500 watts energy wasting halogen. Okay. Let's start. Increasing the speed. %75% of power being fed to this motor. Like the wind pressure is towards this side. Let's turn it off. Okay. Boom. Wow. That was really bright. You can imagine how much energy was stored in the inertia disk. And guys, now comes the 1.5 kilowatt halogen. 1500 watts. I've never seen such a halogen. And guys, size of a 500 watts halogen is this, and this is 1500. You see, it's 3 times the size of this. So guys, now this motor is going to be fully loaded during regenerative braking. Let's connect this. Okay. And finally this terminal, and it should glow. Connecting the motor terminals to the converter. Okay, one done. Second also done. Let's keep it a little apart. Yeah, this much is fine. Let's turn it on. Okay, go. Increasing the speed. 50%. 75%. 85% power. Now let's disconnect it. I have to be quick. Oh, let's hold it. Oh. Cool. So guys, actually the halogen was on the white chart paper, so its visibility was not that good. So I have placed it like this for you to see it better. Okay, so let's get started. And guys, this time I'm going to turn it off from here and not disconnect the wires. Okay, you have already got the point. So it's started. Let's increase the speed. 25%, 50, 75, 85%. Good enough. Turning it off. Let's connect this wire. Whoa. Cool. I connected this wire to the vise because it is electrically connected to this halogen. Let's give it one more try. Bringing it back to 0, turning it on. Whoa. Yeah, actually there was a lot of spark between the clip and the vise, so I think I should better place this directly to the other terminal of the halogen. 0. Started. Okay. Much brighter now. Oh, cool. I forgot to bring it down to 0 and I mistakenly turned it on. And guys, before finishing off the video, I also wanted to test if this regenerative braking energy is enough to start an angle grinder and run it. So let's check that out. Hey guys, I've connected the angle grinder. You can see these wires connected to this pin, which is the wire for the angle grinder here. Okay. Yeah, make sure that it is always turned off. Yeah, it is off. Okay. Yeah, this is the last one. I'm going to finish off the video after this. Connected. Yeah, everything safe and sound. Pointer at 0. Turning it on. Increasing the speed. Turning it off. Off. Oh, so powerful. Really good. That was really nice. It is slowly decreasing the speed. Hi guys, you have already seen this motor in one of my previous videos. So today in this video, you see this inertia disc flywheel. I'm going to touch this disc to the rear wheel of a motorcycle and run it as fast as possible to see how much electricity can this generate with a petrol engine. And also I'm going to do some rope rotation testing with this generator. So yeah, let's get started. So guys, pointing the meter towards 200 volts DC mode since it's going to produce DC. Okay, 200 volts DC mode. Okay. Okay, so guys, keep watching the display screen. 41 volts DC maximum and slowly reducing because of the flywheel. Now guys, the current measurement of this permanent magnet DC motor is going to be very different. Already the disc is very heavy, so it is going to lock the shaft when I'm going to short circuit it with the help of this multimeter. Okay, so let's find the thread and see what happens. Pointing the meter towards current measurement mode. Okay, so guys, now I'm going to wound the thread. Okay. Now guys, you saw that the thread broke, so the only option I'm left out with is doing the voltage mode test and then quickly changing it to the current mode so that the disc, inertia disc charges and we can measure the current without the breaking of thread. So let's do that. So guys, as you can see that at present it is pointing towards 200 volts DC mode. So let's point it towards 10 amperes current mode, and it is in current mode, and remove one wire. Okay, so now what I'm going to do is I'm going to charge the disc with the rope rotation test and then quickly connect this black wire to this terminal, and then we will be able to see the current generated. Actually the wires got short circuited together. Yeah, this seems fine. Once again. Six amperes. Hey guys, I got these super cool car headlamps. And guys, the company is Night Eye. Simple to install it is. LED headlights, save energy, more power for your car. And 9000 lumens, high definition with 3 years of warranty. Let's open it. You can see there is also a BLDC fan at the back. And guys, this is the other one. Pretty nice, right? Both are energy saving type. Now guys, let's wound the thread on this permanent magnet DC motor generator and see how bright it glows. And guys, closer view for the night eye. Okay, super bright. Now guys, let's test the power of this DC generator with motorbike. rear wheel. So guys, these two wires have been connected. Now let's connect them to the multimeter. Yellow positive and black is for negative. So guys, pointing the meter towards 200 volts DC mode. धीरे धीरे स्टार्ट करिएगा, धीरे धीरे, मतलब रनिंग अभी नहीं करिएगा, जब कहें तब। हाँ चालू करिए। अबे धीरे धीरे करना था। ओके, सीधे उड़ा खींच दिए क्या? अरे आपसे चला ही नहीं जा रही है ये। क्लच दबा के मारे रहेंगे तो थोड़ी ना बंद होगी फिर। क्लच दबा के रेस लिए रहिएगा। हाँ आप चलाइए। हाँ स्टार्ट करिए, मतलब एक्सीलेटर लीजिए, वो पहिया चलाइए, पहिया। अबे कर क्या रहे हैं, पहिया चलाइए भाई। चलाते रहिए, छोड़ क्यों दे रहे हैं भाई? हम कर क्या रहे हैं, आप कितनी किक मारेंगे? हाँ चलाते रहिए। हाँ हाँ गियर बदलिए। So guys, as you can see, it is producing 30 volts. गियर फिर बदलिए और बदलिए, फुल गियर। 70 volts. Wow. So guys, here as you can see that I have connected it in current measurement mode. I have to point it towards 10 amperes mode. Now after running it, it is going to display the current. Okay, let's see if it can power this motor in the short circuit current mode. Okay, so guys, let's touch the wheel. As you can see, it is flashing 5 amperes. दूसरे गियर पे जाइए, सेकेंड। Oh, 8 amperes. बंद करिए, बंद करिए, बंद करिए। Oh fish, the wires started smoking. They couldn't handle 10 amperes of course. Oh, the jumper cables got burnt out. Now guys, I'm going to use this in place of the yellow wire, jumper wire. These cables are available very cheap on Banggood. You can buy them from the link provided in the description. So let's connect this one. Well, let's stop the current measurement. Now it is clear that it can easily generate 10 amperes even though it is rated maximum at 7.5 amperes. You can see guys, the current rating shown here is 7.5 amperes. Which proves that the generatable current is always higher than the rated current and obviously at lower efficiency. So yeah, let's start with this 12 volts car headlamp bulb, 60 watts. Okay. धीरे धीरे, ओ थोड़ा और तेज करिए। बंद कर दिए। Well guys, I think the bulb fused. Yeah, I think the current was too high for it to handle it. You see the terminal below broke, got disconnected, and the upper one also got disconnected. Yeah, I didn't think about that. I thought that I will keep it on first gear and it is not going to make or generate too much voltage enough to burn this bulb, but it did. Anyways, let's proceed to the next part. Now guys, the output from this DC generator is very fluctuating, like sometimes it's 12 volts, then after that it is 40 or beyond that. So to stabilize that voltage, I'm going to use this DC to DC buck converter. So the DC buck converter, the input range is 36 to 48 volts, and the output is fixed at 12 to 25 amperes. 12 volts, 25 amperes. And guys, this is a 24 volts 10 amperes, meaning 250 watts. Very powerful incandescent bulb. So I'm going to test it with this generator. Now guys, the bulb is 24 volts, but I have still connected it to a 12 volts DC buck converter. And the converter has been connected to this DC generator. So let's see if it works. First gear. Second. Whoa. 250 watts per flowing. Third gear. Whoa. Well, stop it. Oh, it's working really cool, guys. Hi guys, what you see is the armature of a DC motor. Yeah, this motor contains almost identical armature to this one. I will run this motor just for a few seconds. So yeah. And guys, the plan is to remove the remaining windings in such a way that all of them are gone except for just 2 coils. Okay. So guys, now as you can see, all the coils have been removed except for these two, and these two are joined here at this point on the commutator, and the final end point are this one and this one. So this will be the secondary high current low voltage side. Now comes the part of the high voltage low current side, primary input. Here as you see that this slot, this slot, this slot, this slot and this slot, around 5 slots have been used for one coil. Okay, so I'm going to use same 5 slots for the high voltage primary winding, and I'm going to use this much thick copper wire. Okay, so let's start. Okay, and now I can start it from here. Yeah, I'm going to start it from here. So yeah guys, as you can see, this is how we have to do the winding, and it's a long process, so I'm going to quickly do it and show you the completed process. Okay, so guys, here as you can see that the primary winding portion has completed, and I've given it 120 turns for this coil, and these you already know, somewhere around 7 turns. Okay, so let's glue the winding properly. So this is one terminal, and this is the second terminal for the high voltage primary side. Now comes the second. This is the secondary terminal for the low voltage high current side. So guys, this was all about the electrical circuit. Now comes the part of closing the magnetic circuit, shorting the magnets, electromagnet formation of this armature. So for that I'm going to use this clip. Instead I will do it like this. Okay, so guys, here as you can see that the magnetic circuit is completely closed now. A little part over here and here is left, but all the magnetic field will be focused on this strip. The transformer is complete now. Let's do the winding resistance check. So for that I'm going to point the meter towards 200 ohms. Okay, first doing check for the high voltage winding side, the thin wires, high voltage, low current. So guys, here as you can see, the winding resistance is around 13 ohms for the high voltage low current side, primary 220 volts input side. Now comes the secondary low voltage high current side, and its resistance is only 2.1 ohms, 2 ohms. So yeah, the winding is perfectly alright. Okay, so guys, now comes the time where I'm going to measure the output voltage from this homemade transformer, pointing it towards 200 volts AC mode and connecting the terminals positive and negative to the low voltage high current side. Okay, so guys, the secondary winding has been successfully connected. Now comes the part where I'm going to power up the primary high voltage low current side. So guys, this is the 220 volts supply from the input home socket, and I'm going to connect it. At present it is turned off. So yeah, both the wires have been connected. Now when I will turn it on, you should see some voltage reflected on the display screen. Let's connect it to the main supply. Okay, so guys, here as you can see that the voltage is being reflected as 14.1 volts AC. The transformer is stepping down the voltage, of course. And now let's connect some load to it. Now guys, the secondary winding of this transformer is thick enough, as you can see, so it can easily glow the 12 volts car headlamp bulb and indicator bulb as well. Okay, so let's first connect this indicator bulb. So let's turn on the supply. Okay, so guys, as you can see that it is working and it is glowing this bulb bright enough. Let's test this bulb now. So I've turned off the supply. Okay, so the bulb has been connected. Let's turn on the supply. Okay. So guys, you can see that it is powering up this bulb also, because the secondary winding is thick enough and it can carry current up to at least 10 amperes. Although this transformer is not going to produce that much since it's a modified one, and this magnetic circuit is also not completely closed. Let's turn it off. Now guys, this is just a demonstration circuit. You cannot continuously use this as a transformer because the windings heat up a lot, the primary winding, because the number of turns are not that much. So let's remove the bulb and connect a bridge rectifier to convert the generated AC to DC. Okay, so guys, now I'm going to connect this rectifier to the output low voltage high current side, this modified armature to transformer. Okay, so guys, the terminals of the multimeter have been connected to the output terminals of the rectifier, positive and negative. Now I'm going to point the multimeter towards 20 volts DC mode. Now let's turn on the supply. Yeah, I think the terminals are opposite, because of which it is showing the negative sign. Let's reconnect it. So yeah, now it is fine, showing 0. So guys, let's turn on the supply. As you can see, after the rectification, the supply voltage has reduced because of the voltage drop across the rectifier. And guys, in the beginning of the video I told you that this armature of the DC motor was from a motor similar to this one. So now I'm going to run this motor with its armature. How cool is that? Okay, I think actually the supply is turned off and this wire also came out. Let's connect it back. And let's turn on the supply now. So guys, the supply is turned on. It's a little bit risky because everything is connected to each other here. I have to be very cautious. And now I'm going to touch this terminal and it is going to spark a lot. You see, it is working. Cool, right? Yeah, it is working really nice. And guys, this is the 24 volts 5 amperes, meaning 120 watts motor, Japanese geared, that I used in one of my e-bike projects. You can see the power rating here, 24 volts and 5 amperes, torque of 43 kg centimeter. So I'm going to try and run this motor with this power supply. Okay, so let's connect it. Oops, the supply is turned off. So yeah, I've turned it on now. Let's touch it to the terminal. Yeah, I cannot use it for long because it is heating up a lot. I've turned off the supply.